Alright guys, this is the video for the lesson 1-2 attributes of functions. Okay, this is the video on the homework that we worked on over the weekend, was due this morning, and then we decided to go ahead and extend it, make it due for tomorrow so that we could get the video out. Okay, I did do a lot of the problems. I did not do all of them. Okay, let's see. I did number 1. I did number 3. I did I believe I did 5 and 6. I believe I did 7 and 8. Let's see here. I did number 9 and I did number 11. Okay, so I didn't do all of them. I did do most of them. You are responsible for doing all of them. Okay, all of them. Even the writing part and the reasoning part. I want the regular classes to do those also, just to kind of get your brain working a little bit. Okay. Alright, I've already gone through and worked these out, so I'm just going to hit play and I'm going to narrate as these things play out. Okay? Alright, let's get started on the first 2. Alright, the first one that we're working out is number 1, and this has a graph. Oh, let's back that up a little bit. That's going a little bit fast. Okay, so we've got our graph here, okay, and it tells us that for numbers 1, 3, 5, and 6 that we did, we're going to find the domain, the range, and the x and y intercepts. Okay, let's slow this down just a little bit. There we go. Slow down my playback, and then I'm going to hit play again, and here we go. First thing we're going to look at is the domain, okay. For a line, as you can see, the domain is all the x values, all the horizontal values that it hits. Okay, I'm going to write this in both ways. Oops, let's take that out of there. I'm going to write this in set notation and in interval notation. Okay. So first, in set notation, we say that x is such that x is equal to all real numbers. Okay, that hits all those horizontal values. In interval notation, remember, we use the negative infinity to infinity, and because they are not equal, we use the parentheses on those. Okay. Next, in the green, we're going to be looking at the range, okay? And as we said, for all linear functions, our domain and our range are both all real numbers. So again, we have, in this case, it's not x, but it's y equals all real numbers. And if you're doing it in interval notation, negative infinity to infinity. I'll pause that for a second. Now, you notice that my domain and my range, when we look at the interval notation, they look the same. It is vitally important that if it asks for the domain and the range, you label which one is which. Okay? I don't want to play the guessing game, and I'm not going to play the guessing game. So you need to put that D and that R, okay, so that tells us which one is our x values and which one's our y values. Okay, let's talk about x-intercepts. You will see that as kind of the gold dot there, okay. That dot is at 6, 0, so x is 6, y is 0. I would also, you can either write it as the ordered pair, or you can write it out as x equals 6. I would take that. Okay, my y-intercept you see up here in the blue. Okay, that is at 0, 2. Okay, or we can write that out and say y equals 2. Okay, so that's all for that graph. Now, let's look at number 3. Okay, here's number 3. F of x is equal to 3. Okay, and that is where that essentially says y equals 3. So that is every point where we have y equal to 3. And there should be arrows on that at the end. Okay. Finding our domain, the range, and the x and y intercepts. Okay. Domain. Domain, again, horizontally, we hit all the values. So, we have x is equal to all real numbers or negative infinity to infinity. Now, my range, see that green right there? That's all that it hits. All it hits is the 3's, where y is equal to 3. That is your range, y equals 3. Or if you want to write that in interval notation, we would say just 3 and 3. Okay, equal to, because that's the only number that we're using. Okay, x-intercepts, you can see it's nowhere on there. So x is either the empty set, or you could use the 0 with the line through it. Okay, now y-intercept, of course, what is it? 0, 3. Okay, so y is equal to 0, 3 is our y-intercept. Alright, let's go on to number 5. Okay, number 5, let's change. Alright, here we go. H of x is equal to negative x cubed. Okay, we're going to write out a t-chart here to get our equation going, get our points. Okay, x and y, so we're going to do negative 2 is equal to, remember our equation is y equals negative x cubed. So we have negative times negative 2 cubed. Okay, that turns out to be negative 8 or positive 8. Negative 1 ends up giving us a y value of positive 1. 0 gives us a value of 0. 1 gives me a y value of, speed that up a little bit, of negative 1, and 2 gives me a y value of negative 8. I plot out my points and I connect my dots, and there is my negative cubic function. Okay, arrows on both ends because it continues on. Okay, so we are going to be talking about the domain, range, and intercepts again. Alright. Domain in the orange. Again, it hits all horizontal values. As it goes up, it continues to go out. Okay, so negative infinity to infinity is our domain. As it goes out, it goes up and down all the way. So our range, in this case, is also all real numbers. Negative infinity to infinity. Okay, in the gold, you'll see my x-intercept right there at the origin. So where x equals 0. And my y-intercept is also at the origin for y equals 0. Okay, number 6. K of x equals 4 over x. table of values. We're going to go from -4 to -2 to 1, 0, 1, 2, and 4. So, -4, if x is -4, I get a y value of -1. If x is -2, I get -2. -1 gives me -4. At 0, can't divide by 0, so that is undefined. That is our line of asymptote. Okay, 1 gives me 4, 2 gives me 2, 4 gives me 1. Okay, plot out my points here, draw my graphs, trace out my lines to connect my dots. There we go. Arrows on both ends to show that they continue to go on. We're looking for the domain, the range, the x and y intercepts. Okay, in the orange, notice, I'm going to pause that for a second so you can see this. Notice that my line did not go all the way through. That is because at 0, my graph is undefined. That's where I have that line of asymptote right there. Okay? Alright, and also right here. Okay? Alright. We'll back up. We'll get that one in a minute. Alright. Let's go on. So, my domain includes everything but 0. So, I end up saying, for my domain, x is such that x is not equal to 0. Okay? Now we can do interval notation if you want to. Interval notation would look like negative infinity to 0, not including 0, and 0 to positive infinity, if that was how you wanted to write it out. Okay? Look at the green. Again, the green has a gap in it because there's our horizontal line of horizontal line of asymptote. I don't know why I just lost that word. Okay, so for my range, I have y is not equal to 0 for my range. Okay, and then you notice that nowhere is that graph going to cross that x or y axis. Okay, so my y-intercept is the empty set, and my x-axis, let's try that again. My x-intercept is the empty set, and the y-intercept is also the empty set. Okay? Alright. That takes care of those first graphs. Now, let's go on to number 7 and 8. Number 7 and 8 ask us to find the minimum and the maximum on an interval. Number 7 wants, there's my graph for number 7. Okay? It wants the minimum and maximum on an interval of -1 to 3. Now, I have shown you at my -1 and at my 3, there's my lines of my interval. Okay, so we're looking right in between here. Okay, so anything from here to here. Okay, including those lines. As we said, this is, let's do a different color. This goes in one direction, right? Okay, it continues to go in that down direction that doesn't change directions. Okay, so we're going to look on the ends. Here at the purple dot, okay, that's where I'm going to find my maximum because it starts out high and goes down low. So I'm just going to count up, and I find that dot at -1, 1, 2, 3, 4, 5. So -1, 5. So at -1, my max is at 5. Okay, then I'm going to look at 3. I'm going to look on the other end at the red dot here. Okay, that goes over 1, 2, 3 and up 1. Okay, so when x is 3, my minimum is 1. Okay, graphing out the graph for number 8. Okay, 8 has an interval of 2 to 4. We'll put in those interval lines right there. We are looking in between and including these lines. Okay, so this one, you notice this goes up, right? This one's going up. The other one was going down. This one's going up. Okay, all right, so my high end is going to be on the right, okay, where the purple dot is. My low end is going to be on the other side, on the side of the 2. This is 2, this is 4. Okay, so my maximum is at 1, 2, 3, 4, 1, 2, 3, 4, 5. 4, 5, so my max at 4 is 5. My minimum where the red dot is at 4.5. Okay, we can figure that out because we go over 1, 2, 3, 4 and up 1 to for our slope. It has a slope of 1/4. Actually, it's up 1 over 4. I'm sorry. Okay, so if I've gone up 1, when I've gone 2, I've only gone up halfway. So that tells me that's at the halfway mark. Okay, so I go 1, 2, 3, 4. Let me actually show that. 1, 2, 3, 4, and then up my 1/2. Okay, and that gives me the 4.5 for my minimum. All right, let's look at number 9. Okay, number 9 is g of x equals x cubed plus 3. They want us to complete the table of values to get our points, and then they want us to compare it to the parent functions, and then describe any change in the domain, the range, and the x and y intercepts. Okay, it gives us x values of -2, -1, 0, 1, and 2. When I insert -2 for x, that gives me -2 cubed plus 3. -2 cubed is -8, plus 3 gives me -5. Okay, then for -1, that gives me -1 plus 3, which comes out to be +2. 0 cubed plus 3 is 0 plus 3, or just 3. 1 cubed plus 3 gives me 1 plus 3, or it equals 4. And then 2 cubed plus 3 gives me 8 plus 3, which is 11. Okay, plot out my points, connect my dots. Okay, and we are going to be looking for the domain, the range, the x-intercept, and the y-intercept. Okay, but before we do that, let's graph out this this function here. F of x equals x cubed. Oh, I'll have to go back and fix that in just a second. Okay, so we have y or x values of -1, or -2, -1, 0, 1, and 2. When I have -2 cubed, that gives me -8. -1 cubed gives me -1. 0 cubed gives me 0. 1 cubed gives me +1. And +2 cubed gives me +8. Okay? plot that out. Connect those dots. Okay, let's fix that real quick. F of x. There we go. Okay, let's look at the domain and the range of each of these equations, okay? Our parent function in blue has a domain of all real values. And as we can see, the domain on the red graph, the changed graph, is also all real values. Okay, so negative infinity to infinity. So here we see no change in our domain. Okay, now in the green, look at our range. We can see that these graphs are both going to go up and down forever. Okay, so our our range is also, in this case, all real numbers. Okay, so we see no change in the domain or the range with the changes in this graph. Okay, now x-intercept for my parent function. Okay, see that gold dot right here? Okay, my parent function has an x-intercept at 0. X equals 0. Okay, now my y-intercept, not my y-intercept, my x-intercept for my my changed function is right up here. Okay, but how do I get that number? Okay, I want to put 0 in for y, and I want to solve for x. Oh, I said that wrong. I showed you the y-intercept. I want the x-intercept right here. Okay, so I'm going to put, when I have the x-intercept right here, we know y is equal to 0. So we put 0 in for y. Okay, we're going to subtract 3 from both sides. Negative 3 is equal to x cubed. I'm going to take the cube root of negative 3 is equal to x. So my intercept is at the position, and we would put that into a calculator and get that number. But the cube root of negative 3 is that gold dot right there that's circled. Okay, we can tell that we moved from here to here, right? Okay, so that moved, to the left, cube root of negative 3 units. Okay, so here to here, it made that shift. Okay, let's talk about the y-intercept. Y-intercept for the parent function is at 0, y equals 0. Okay, and then right here you see the y-intercept for the changed function. We can count that very easily. 1, 2, 3. So that moved up 3 units. Okay, and we'll start to see that 3 in there. Okay, when we add that 3, that shifts everything. Okay, it shifts it vertically, and when it shifts it vertically, it shifts all points vertically. We'll talk about that more as we get to cubic functions next semester. Okay, alright, number 11. Okay, Aria is having a bowling party for her birthday. It costs $3 a game to bowl. Shoes cost $2. Okay, let's do a quick graph of that. Okay, Here in just a second, we got A wants us to write a linear equation to model the cost C of X of bowling X games. Okay. B wants us to figure out the domain, the range, the x-intercept, and the y-intercept, and explain their meanings. Okay, graph this out. First of all, we have an equation. It costs $3 per game, so that's 3 times x, plus $2 base to get the shoes. So when I have x is equal to 0, I get the base $2. When I bowl one game, I have paid $2 for the shoes and 3 for games. That's $5. For 2 games, I'm going to end up paying $8. For 3 games, I'm going to end up paying $11. Okay? Plot out those points and draw that line. Now, why did I not graph the negative numbers? Well, it's a real world scenario. You can't bowl negative games. Okay, so we're starting at 0 and going from there. Okay, on the number of games that we're going to bowl. Alright, let's look at this domain in orange. Okay, it starts there at 0 and it goes through infinity. So that gives us 0 inclusive, and so that's equal to, and through infinity. Okay, what does that tell us? It tells us we can't bowl a negative number of games. Okay, range over here on the right, in the brown, you can see it starts at 2, so equal to 2 and going through infinity. Okay, interpreting that tells us it costs us $2 to get shoes before we even start playing the games. Okay, so we have to pay that $2. That's just our starting fee. Okay. Now, x-intercept, if you look, it starts above the x line. Okay? So, we don't have an x-intercept. We do, however, have a y-intercept at 0, 2. The interpretation of that intercept tells us it costs us $2 to bowl. Before we even bowl a game, it's going to cost us $2 to get those shoes. $2 per person, that is. Okay, $2 before any games are officially played. Alright. Well, that gets us most of those homework problems. Y'all finish up the rest of them and get it all submitted. Y'all have a good night. I will see you tomorrow.